wasn't really.
And we from the transport system, our start. The patient is sorry 2 years for female, so this patient. And for patient, one start when she was female. She said it happens 5 times a year, and longest duration was 5 minutes. It starts suddenly, and there is no testing part story, and as thoracic cardio show function. This is 12 already CT in an outpatient clinic. It shows that away. There is no documented cardiacis. When looking closely, this is delta wave is positive negative in V1 and also positive negative in VBA. According to our algorithm, it seems to be located below subparameter. Just X-ray was normal. Start with yes. This is the initial positioning. First, we engage primary side. As this picture shows, we try to engage primary science with innovation and cell one case for failure. This is the initial normal science expectation. During RV testing, RSTA signal was reported that this start is there then. And it showed wrong VH. We reached the VA block cycle length at RVP for 20 milliseconds. And notably, VA conduction time were variable, not always equivalent. During single ventricular extraction test, 600 or 8 milliseconds, you can see the echo bit with all this state signal at around the echo. You want this around this force. And there was a create commenter. We reached the VA, so there is a ELP at 600. 38. And 602 here was a failure. We start the facing in 20 milliseconds was a visual upside frames. And during single arterial stress condition test, it seems there's no perimeter property in surgery. 690 milliseconds was accessible to ELP. There are still the test. There's no AH jump until AELP. At the base DPS, we fixed the catheter positioning and this catheter was inserted in right position. Isoproterenol 1 microgram mini was we repeated the test. We can see the comment output again. Then there's a single copy without any jump, or maybe a junction of it. At single arterial assessment as 603 at 628 milliseconds, we can see bit again. Because there's a question in conduction until 630 milliseconds. We reach the accessor factor ERP at 820. So we start the mapping using relation factor. the right step, and there was no settlement. So once the tire puncture was done, and that's the in the side. We found, I guess, like that at the posterior septum, and we checked the fundamental property of accessory casting, which always be. We repeat the test, but there is no definitive non-direct path. So this is the summary. This is to show the possible posterior septal occasion of accessory casting. Originally, retrograde the picture activity was at the start is, as you can see. And we can see the related fundamental property, most definitely fundamental property of anterograde scissor justification. And there's a COVID without the initial doing singular text that we mentioned. And with us, a quaternary infusion accessory ERP was restored. So impression was a high risk to the requesting if the posterior septal area.
What do you mean high risk? High risk for what?
Patients develop a risk to ERP equation.
The high risk of suddenness.
So is it the single echo beat? Or back EGM? Which bit is conducted and which bit is echo beat? Or if you say this is echo beat, then if you are saying that is A is conducted to laptop, please, then you can explain that, please. It's more like consonant.
So the last page bit is a pre-excited, right? So it's we don't see his bundle there. So it's a conduct through the maybe fusion, maybe pathway. Okay, because your CS proximal D earlier than QRS still. So that 9, 7, 7, 8, and 5, 6 V is earlier than delta D AV. Or the 7, 8, 7, 8. Yeah, that's a B. Yeah, that's earlier than delta. So there's evidence that this bit went down to delta, actually pathway. Okay. And then the other one is a possibility, your question whether this is a junction escape rhythm or this is what it might be. So we was having discussing about this is that this is the junctional bit. Your HEV interval is a little bit, Dr. Park arguments is longer, but I'm not sure it's longer. It's about the same, I think. You see following the sinus HEV interval. Can you see that? HEV right there. But that looks pretty same. Well, except the difference is what? Activation sequence of RV. You see it? If this was if you junctional rhythm, RV activation EGM shouldn't be the same, right? Because you're going down the same pathway. So clearly, RV activation in the proximal is reversed for some reason, and which is similar to the same as RV activation of what the pathway in the just preceding lead B1. I mean H12. Look at the QRS morphology. Vector looks like the same, but then only EGM slightly changed. So argument was here that whether this is long conduction, double A response. Otherwise, you can explain this EGM. Second, A, B in the CS activation is in an A almost inside the QRS complex, the echo beat, right? If this is not a ventricular echo beat, this is gotta be nodal echo beat. Look at the CS5 and 6, the echo beat itself. You see, AV together, just like AV nodal. So junctional rhythm is one possibility. We can expect suddenly possibility, but also there's a possibility of this long one stimulus 2A response. So it is an argument that we are having early.
This case is a very complicated case.
Right.
And there's many combinations
Right.
potential of the accessory pathway
But
physiology.
yeah,
And I thought during the procedure, I saw that there's decremental property and no retrograde conduction. So I tried to prove with Smaheim, but eventually I failed. But there is another combination of the rare accessory pathway without retrograde conduction, or combined nodal vascular,
right.
or combined AV node, the dual AV node
Right.
physiology. So we conducted differential diagnosis from atrial vascular to nodal vascular and every kind of combination. But so that's why I argued with Dr. Wang very much.
So I told them that it's not a
But
Mahain.
still, I believe it is junctional rhythm because
Well-
the his bundle polarity is different, right? And also, I assume there is another possibility because if it is real junctional rhythm, there's no delta. In other words, that accessory pathway bypass his bundle area.
But
Okay, yeah. But
similar argument that this could be echo beat also. During the echo beat, you have no delta.
So even during at the faculty dinner meeting of KHRS, I asked this finding to Dr. Scheinman, and he told me the Kant bundle without retrograde conduction is extremely rare.
Right.
Yeah.
But I think it's interesting because when you have a pathway close the postal septum, close the slow pathway area, many pathways will involve some degree of influence of decremental conduction, even though it's not a decremental property because it's simply electrotonic nodal conduction issue. So it is a challenging differential diagnosis whenever we involving not through postal septum, but a little bit more toward the upper septum, and then we get a lot of trouble with that.
So is it possible to the AV nodal conduction prevent the retrograde conduction?
Exactly right. Electrotonicity. That's what I talk about. Yeah, because it's a slow conducting tissue. Also, refractory recovery is somewhat longer than normal. Other issue that dominant conduction. Remember, cardiac tissues when you condition the tissue, so one direction conduction, they tend to conduct that way faster. When you try to reverse, conduction speed much slower. There's a I think there's a PhD thesis written by Candido Cabo. I think that I was one of the evaluators of that PhD thesis. He just demonstrated very nicely when you suddenly reverse in tissue model, culture model, electrotonic activities, when you try to reverse, conduction velocity drop down to almost 30%. It's a very nice paper. That's one of the actual functional reentry mechanism of reentrant tachycardia. Anyway, this is just the page note. So I think that same thing happened here. Okay, that's why, for example, patient have a frequent PVC and RVOT or LV close the septum. What happened? You can constantly colliding with the anterior conducting pathway of the nodal conduction. Instead, continue feeding retrogradely. That eventually create a retrograde slow fast dissociation. Then have a much higher incidence of AV and RT in those patients. That's just one of the hypotheses that Pepe Halifi always argue about it. We cannot argue on that because he's a Candido Cabo, associate. So, which are all possible. And which is true, that is true as well. So anyway.
So you told we measured tested the decremental property at the site of accessory.
Right, you did, he did. Show the ablation, yeah.
You made me very confused. Did you see the decremental conduction or not? Initially, you told there was a decremental conduction, but later, no decremental conduction.
Oh, is it decremental conduction?
Please clarify.
Okay. There is I think a certain, misunderstanding about people measuring that conduction properties based on the stimulus. No, that's wrong. Because the stim to the capture can be longer than each decremental. So you need to measure actually EGM to that conduction, not the stimulus. Simply stimulus is easier to see. People measure that. That's a big mistake. Don't do it. Especially pacemaker implantation. You need to measure actual EGM to the conduction, not the stim. You can have a first degree exit block for the stimulus, Wenke block, 2-to-1 block. You can all these things. So that measurements that you're drawing line there, not right. So you measure, but obviously we need a good responder as well to see that.
If you look at the CS78, not the green color shading. I don't like the green color. Color it. No, electron. Don't do that anymore. Okay. No, it's okay. Okay. Yeah. Okay. If you look at the CS78 in the 300, 400, it's a little delayed.
Yeah, it is.
Very high.
It is.
So
To the local capture.
although I thought, oh, it is real Maheim, but afterward, with AV interval is same.
Yeah.
So
Because stim to the, that's why,
physiological.
right, that's why I commented you, stim to the, your capture is longer, extra stimulus. That's why I told him, you're not, this is not behind.
Even with the accessory pathway, there's a small delay by physiological.
And I'm just gonna tell you a story about the Maheim. Maheim is left side that reports the cases are from China, published in Frontier Medicine, okay? That paper, if you read it carefully, it did compare right side and left side Maheim cases. And if you look at the AVL, that tracing of the Maheim left to right side, both negative. That paper gotta be wrong. Something fishy about that paper. They did so many Maheim cases and they said the 4 was left-sided. I said, no, this is garbage. We have not seen yet left-sided Maheim, at least in the United States, as far as I know, any published documentation. So I don't know what the truth is, but anyway, it's suspicious that the paper may not be right. Okay.
Okay, please go ahead.
But if you're just pointing out to you guys go to the very first slide, you made the wrong catheter placement, but you did the right thing, fortunately. I want to just tell you one question, quick question. First, the tracing. First one, intracat. Yeah, there you go. If you look at your undesired catheter placement, let's put that way, and your CS did not go in, but CS catheter distal tip was pointing superior roof of a coronary sinus proximal region. Look at the EGM there. Very tight AV interval with some kind of notching in between. Do you see it? So I wonder if you saw this and then his last ablation signal that you guys ablated, which one is better? Huh? What do you think, Dr. Bob? Would you, if you had the two choice, which one you ablated? Well, that's what I'm asking you.
First one, CSD star was not inside the CS.
Doesn't matter.
If you look at the electron.
Yeah, it's in the posterior septum, right?
Yeah, so before ablation, I mapped the right side septum, low crista, inside the CS. And
How come you do not see this potential?
I don't know.
Because you moved the catheter and probably didn't look enough.
So
I mean, if
right side was not
if I was, looking at this, I would ablate right there.
No.
Would be done.
Trust me.
No. Your signal in the other side.
I eliminate potential by single bond.
Yeah, but show me the tracing, the last one. Last ablation signal, you had the last slide. That's always my question. Why this guy did not burn that area and moved around?
Oh, it is not the perfect capital position.
Okay, take a look at it. So,
Yeah,
this is one.
Successful ablation site there.
There you go.
Yeah, look at the signal. You got A, and then you're probably targeting ventricular insertion, maybe. But there's no catheter potential between. Okay? So look at the signal. And then you have a local A is a negative. So it really bothers me quite a bit.
이거 맞아? 이거 마음에 안 드는 거.
You see? That's what I'm telling you. Don't listen to all his argument, okay?
부스터 오블레이션 아니야?
No. When I look at your signal, I said, how come what oblate here, not there. That's what I was wondering about it. Anyway, that's just a side note, because the reason I say that,
토론 이후로 그냥 화나게 온.
so my argument is that, maybe right side could be, if I was hoping to answer to me, a right side, I thought there was a higher risk. Yes, I couldn't argue on that. However, signal wise, this is not better than first one. Okay, I just want to point out to you. But obviously, you need to assess, make sure that you're far away from his bundle and so on. Okay, because that CS catheter pointing upward. Look at the first catheter placement. Look at the inside of the septum. So you ablate that area, you potentially could knock down his bundle. So I'm just trying to raise this issue with you guys. Think about it. Okay. And I always have fun arguing with Dr. Park about this because I tell him,
윤 선생님,
yeah.
땀 구경이 제일 재밌지.
So delta disappear within 4 seconds. This is during the burn.
This is the start.
This is during the one, right?
그래서 오블레이션 시그널
저기 있잖아. ablation on 저기.
어디 있어? 어디 있어?
근데
Behind it.
아니 거기 있잖아. ablation on 저기 있잖아. 저 꼭대기에.
Hide
근데
intentional.
I have a question for you. How come delta wave got bigger during the burn? Is this normal? Looks like acceleration, pre-excitation. Look at that. Before the block, no block yet. I have not seen the conduction block yet, but then, I mean, it got bigger and suddenly slow down, narrow down again. So I assume that blocked the next speed. Yeah, the block, I can see narrow complex at the very end of it. So why this automatic behavior? Maybe this pathway was a closer area where you have an automaticity for tissue. That's why you're burning.
But this patient showed the delta augmentation was shut.
Right, that's what I'm saying. So maybe there is a nodal-like tissue involved on that area. Otherwise, I wouldn't explain this because it exhibits some automatic behavior. You not typically we see this in the pathway ablation. So maybe a slight documented conduction of that antegrade conduction of pathway maybe involves some little bit of nodal tissue.
I didn't see any Mahaim light.
More, you're not going to see that area is too low.
I don't
Yeah.
think it's.
I don't think it is, but then either ablation responses could be bystander, but I cannot explain why the pre-excitation got bigger during the burn. You have to have this automatic tissue firing itself near the atrial insertion to have a pre-excitation, such as because you
Okay.
can see your lesion Q in the look at the atrial signal, CS56. See that? Getting QS now. Then you suddenly have this response. So
Okay, please find out, add the ablation signal and send me by email, please.
and also send your first slide as well to him, so you can look at it again tonight.
severe narrow QRS complex
Yeah, last one, last in narrow complex.
in May junctional rhythm.
Yeah, that's what I said. That's what I'm asking.
그다음에 어떻게 했어요?
So I would like to see the
Local rest of it, right?
after this EGM during sinus rhythm.
So
Narrow QRS complex during sinus rhythm.
that maybe explain why maybe you're blaming near the left side slope pathway somewhere.
Yeah, Dr. is right. Even though the before ablation, we saw the narrow crest with junctional rhythm.
Right.
So you cannot prove it. We are successfully ablated at this moment, right?
So after the PR got normalized, then so this is the junction rhythm. So you can add one more slide there after that and then send it to me. Also, let me take a look at it. I'll try to excite a little bit more Dr. Park.
Excited enough.
Oh, you're not missing the first potential. Actually, when you have the first catheter placement, it is typically sometimes we apply inside near the coronary sinus slope pathway, that area. That's I was interested to know whether this was any documented conduction. you ask me the Mannheim, so no, it doesn't look like a Mannheim, but there is a slope head involved. As I told you. Anyway, Dr. Chapman doesn't know either, so, okay? All right,
With
there's still junctional rhythm there. After pacing.
maybe doing either attract or something, I don't know, age.
Okay, oh, there we go, Doctor. No delta there now. Yeah, it's normal.
Maybe use the big one using other machine and you want to focus it. This is different times to the calculation.
Now, I have this question about this, always you guys give adenosine. If you have a nodoventricular or nodovesicular pathway, what's the role of adenosine after ablation? Did they help you? Doesn't. Yeah, both adenosine sensitive. So why you're wasting your time?
But this patient has can't bundle.
No, I'm asking that question. I mean, routinely use adenosine is not a.
He did, so.
Are you playing him?
Yeah.
You're the boss.
I asked him to don't do that anymore.
No, you saw.
Are you still giving adenosine routine? No.
I'm just see, very common practice people give adenosine after the pathway ablation. I said, wait a minute now. Maybe you can argue that the left side pathway, right side of it, and so and so. But if you have nodovesicular pathways or either atriovesicular pathways that involve tegmental tissue, they are adenosine sensitive. So adenosine giving post ablation does not prove you failed the success. Okay, so don't waste the time and money to the people. Okay, it's not common to see that practice. Okay. Okay.
Oh, review, okay.
All right. Let's go.
A short video about, let's just say, without the forward. This is data from our lab.
Oh.
1994 to
Wow.
2024 about patient with SVT. You can see gradual increase of total case numbers. The bottom chart. And graph show the proportion of each case.
What happened? 2017 and 2022.
Unfortunately, there is no data in the theory. I don't know why.
We lost faith.
No data.
Somebody did not put an archive. They're working on it.
내가 랩이 셧다운 됐었는 줄 알았어.
So you can only use the data up to that, whatever that cutoff. Okay. Anyway,
The proportion of WW pressure was gradually increased as other proportion of passenger increased. Anyway, total about 12,000 cases, 3,003 cases were WW. And of that, only 10 cases were reported as regular pathway without progress induction. And 7 of them were mechanic pathway. Just 3 of them were actual
Oh.
pathway. They're all pathway.
you have a mime that left lateral. We need to review that case. Definitely.
어디서?
여기 있잖아. Left mime, left lateral.
땅땅땅 한국 사람 아닐 거야.
But the data you should have though, tracing. 1997.
저는 절대 없었어.
I think it wasn't, beginning the fellowship even. 97. So that would be interesting to review that case.
좀 해보시죠.
So there are few papers about this relax center pathway. One of them was published in 1997. In this paper, they analyzed and they say that there are fibrillation with fixed station was visual presentation in this.
That's about right. Yeah.
Elimination of this pathway will prevent the recurrence of symptoms atrial fibrillation in younger patients without CFD.
So in the,
너무하네.
in what I can tell you,
밝혀봐.
yeah, Dr. Bach asked me earlier, what's the incidence of anterior-conducting pathway only? And without knowing is any of this data. I remember in the 2005, we had NASB and HRS-wide sort of a survey, and then we discussed about that. My record was 5 to 8% was only anterior conduction only in US. And then surprisingly, he told me that in Yonsei University history only had a 10 case over 3,000 plus. I said, wow, that's something that unusual. So I think there's something missing here. And then also we need to review, look at that left side, the lateral behind. Okay. If you have a data, I have to look at with you because this is not something that usually I heard about.
옛날 데이터를 볼 수 있어요? 97년도 데이터? 어려워요?
강화도
어디가? 강화도?
자료를 다
자료 보내버려요. 어디로? 강화도로?
올드 EP
그래서 어디로 가?
트레이싱을 강화도 창고에
여기 강화도 찾고 가서 연습돼? 거기 가야 돼?
여러분 가죠.
그럼 날 강화도 가야 되는가?
자원자.
같이 가야 되겠는데? 강화도 가서 봐야 되는데 이거?
저 밑에 환자는 엄선생 환자인데 아마 인덕션 안 돼서 오블레이션 안 했다고 들었어요.
네,
그죠?
맞아요. 이분 최근 팔피테이션이었어 아마.
근데 이 환자는 패드가 없었어. right side, left side. 2010년? 2012년이네.
이렇게 다 남아있으면 항목별로도 없는 부분이 되게 많아가지고.
그래서 우리 기억으로는 저 미국 데이터 보면은 right side fluid pathway 중에 anterior conducting only pathway가 많았고 left side is very more dominant retrograde, not antegrade. That's what I remember. 네, 여기는 very unusual this pattern here. I never heard this before.
40년간 97년에 내 케이스가 발생한 거는 당시 약간 경험 부족, 스터디 부족 아니었을까요?
그래서 일단은 좀 데이터를 찾을 수 있으면 좀 보면 좋겠네. There has to be something unique. 근데 그 당시에 이제 얼만큼 well documented 되고 그 다음에 extensive하게 매핑했는지 모르겠지만은 it's everybody's starting ablating since 1997 in Asia probably. We started in 1990 and yeah.
I hope Dr. Chunyoung Lee will summarize the unusual bypass rate presentation someday. And after experience this complicated case, I'm not sure that my thought is right or not, but even though the many the scholars classify those unusual bypass threat, but I think it depends on the anatomy, fiber orientation, and the normal electrophysiology of those characteristics. So there's some mixture of bypass threat.
I think we know much more about WW than now, certainly. However, I don't anticipate any further development or update going to come out of developed country because the WW is extinct there, pretty much. Because most of it done by pediatric people, first place. Second, they never get to really to the adult population, not that many of them. Actually, this type of work you were talking could be much better off than in the where we serve volunteers, Mongolia, Myanmar, and Cambodia. That's why we said it's very unusual that we had a left-sided nodal ventricular pathway in behind and pathway same day on the Myanmar. So it was a very fun day. But then those type of things, I think we have to focus on when our junior schools together, we can educate them all together. That's just much more interesting to share. And certainly is much more interesting than just doing AFib ablation, that's for sure. This is boring cases. But this is sometimes you really need to do EP maneuvering and so on, but you study. Okay.
So I'll give you homework today, including the junior steps. Please looking for the how to differential diagnosis for between atriovascular and nodal ventricular. Okay, just two.
No, three,
That's it.
actually. Nodovesicular, nodoventricular, atriovesicular.
Then if there's too many, that
No, there's not too many. There's a,
they
because,
will be confused.
no, nodoventricular, nodovesicular is pretty similar. So just a very quick differentiation. It's not big
If
deal.
you can differentiate atriovascular and nodoventricular, probably other unusual bypass rate easily differentiate
Yeah,
during your procedure.
so also, when you involve with both limb, anterior retrograde limb involving decremental conduction property, you can get very easily confused about it. So,
Okay. 감사합니다.
okay, thank you guys. Appreciate it. I'll see you next week, I guess.
아, 괜찮아요.